I, Benson Odhiambo-Otieno, from Moi University. I'm hereby to talk about the industrial attachment, industrial trip 2. I'm hereby to talk about that, and I'm going to concern and talk about the electrochemical machining. Electrochemical machining, this is the process of dealing with removing of metals instead of depositing through electrochemical process. It uses the Faraday principle, and this Faraday principle, we saw that the Faraday principle, it is talking about the electrolysis and the electroplating. Let me start with the electrolysis. Electrolysis is whereby we have the cathode and the anode. The anode is the positive one and the cathode is the negative one. So you will find that when this process takes place, it is there to remove the gaseous layers when electrolyte is there. And this is also to improve, also this process is used to improve the polishing of the metals. It polishes the metals using the electropolishing. This process, it is there also to do what? To increase the toughness, the hardness, and the strength of the material. Going direct to electroplating, we saw that electroplating, this uses the mass production and extremely hard materials that are difficult to machine using conventional method. We have also seen about that electrochemical machining. It uses the examples of electropolishing, uses the non-conventional polished. It also uses the anode and the cathodes. So you will find that at the anode, the metal dissolves electrically. When the metal dissolves electrically, it forms that polished. It forms the polished outside the metals, and this process also, it is also applicable in the electroplating and electrolysing. When the high current passes through the tool, and the tool is the cathode, and the workpiece here is the anode. The anode is the workpiece, and the cathode is the tool. So we find that this process goes through a conductive fluid, and the conductive fluid here is the electrolyte instead of dielectrics. The examples here that we have, the examples of the factors we have here is the ionic charge. We have the current charge that is passed there. Examples of the factors we have here is the ionic charge. We have the current charge that is passed there, the time that is also passed there. So those are all about the electrochemical machining. Electrochemical machining, it's used to increase the strength, the hardness, and the toughness of the materials. And it also improve the polishing products of the materials. I'm going to talk about also the threading and threading cutting. What is that entails? The threading, it is used to see the threads, the number of the threads in a metals. So it uses a cold roll steel of 20 millimeters. In there, we also use the vernier calipers to measure the inside and the outside diameters of the threads. Which also use the metric spacing. That is, metric spacing can be used in 4 millimeters. And also we have also the thread gauge. The thread gauge is used to measure thread distances, and we also see that the number of times when, for example, 10 times, that is 10 times of the helix, it brings the movement to 25 millimeters. We also use the change gears. We also use the gearbox. So on the thread cutting, it uses the cold roll steel of 20 millimeters. It uses the vernier calipers to measure the internal and the external threading. So it also uses the metric spacing. The metric spacing uses the 4 millimeters. So this one is also applicable in the to improve the number of the threads machines. So thread machines. So the thread machines that we are talking about here is the thread tools. So this thread tools comprises the tool post. The tool post is the thread cutting tool that is about 60 degrees, And we are also talking about the gauges. The gauges are used to measure the angles. These angles can be 30 degrees, 30 degrees, 60 degrees, and also 29.5 degrees. So you will find that this process is accompanied by the following procedures. So you will find that the workpiece is held between the center of the chuck, and the tool is held in the tool post for producing the threads of pitch at a certain millimeters that you have chosen. So you find that the tool must travel a distance equal to the millimeters that you have chosen as the workpiece makes one complete rotation. So we will find that that rotation, it is whereby we use the tool cutting the tool cutting thread that is around 60 degrees, and this 60 degrees we can also generate it to produce the 30 degrees, and this 30 degrees you can also generate it to produce what is called 29.5 degrees according to the number of the threads that you want. So the number of the thread that you want is you will use what is called the thread gauge. This thread gauge is used to measure what? The thread distance. So this distance can be the number of times the thread successive distance you want. For example, you want 10 times. The 10 times you can use the following. So first you will use the change gears. Secondly, you will use the gears, the gearbox and the helix. So this helix, it will be there for you. It will be there for you to start turning the helix at a certain times that you want, that I've talked about. So you are going to also to talk about the using a die handle, in which is using the method of external threading cutting on the lathe machine. So the workpiece is composed in that lathe chuck, and the